Okay? So if we're going to evaluate that limit, what would we do? It's been a hot minute since we've done the limit. Sorry. It was the best I had. I just needed, yeah, we just plug it, right? We substitute. I didn't have Parker's beatbox in there to help me, so, you know, just had to do what I could do. Oh, where's my pen? Get over there.
Sorry. This?
Yep, that'd be me. Thank you, Amy. You conducting major business over there?
Yeah, sorry. I'm sorry. I was finished.
All right, so we would substitute. That's just the easiest way. And so that would give me 5 times 2 minus the cosine of 2 minus 2. Or 10 minus the cosine at 0. What is the cosine at 0? 1. And so our limit would be 9. So the basics of limits, we simplify or we evaluate by just completing or by doing direct substitution. Does that always work? No. Okay. Okay, I have caramel pecan sugar cookie today. It's so good. All right, here's our affirmation. However difficult life may seem, there's always something you can do and succeed at. Okay, Mr. Hawking. So we're going to talk about L'Hopital rule. It looks like L Hospitals. Okay, it's not L Hospital, it's L'Hopital. All right, L'Hopital. And his great thing, his contribution to mathematics. Yeah, La Hospitals. All right. So limits help us to predict y values that are very hard to determine, but sometimes the numerator and the denominator send mixed messages about the behavior of the function. How can we make sense of this and send a clear message about the function's intended y value? So there are several things here I want you to look at. On 2 pages, there's about 6, 7, 8 questions. So take a second and work through those with your table groups. All right. And then we'll talk about them. Correct.
Excuse me, students that are going on a trip to TBA, please come to the cafeteria at this time. Students that are going on the trip to TBA, please come to the cafeteria at this time.
Didn't hear you. It just gets smaller. That is no mathematical sound.
Well, but like, that's how
Sure.
You know,
yeah.
because it goes bigger.
I would be happy.
It makes sense though. It makes sense.
So for 4.
Slopes log and that grow.
Because it's a small road.
So whatever, very high intensity over a very small.
Medium affinity.
Medium.
Are we clarifying infinity? That sounds fun.
The medium infinity.
Yeah.
It's like, it's not like all the way.
Growing at a faster rate.
I mean,
Just a little infinity.
oh,
Like it's a little bit.
well, I watched the.
No, we're definitely right. We just gotta meet in the middle,
I
that's all.
read the book.
Yeah, I can see why.
Oh, you're not very They're both nerds.
The thing is, though, they're going at 2 different rates.
Hold on.
You can't cancel.
I know, I can. It's gone. It's gone. It's in remission.
Yeah, Jacob, if you have cancer, you really
You
can't.
really can't say.
So we're fine.
Evaluate.
Yeah, and
He doesn't have
Vinny's
cancer anymore. He doesn't have it.
He thinks he doesn't have it.
That's the same
Do
thing.
you think that he gets a free pass for the rest of his life? to say,
It was
small.
small.
No, it's definitely
You think that was
You
true?
did have cancer. No, one.
slash.
See, even
That was your
Gary.
turn.
Gary doesn't even hear me.
Because it's gonna be ending on the bottom, so just.
Why are you eating your
Really
phone
was-
sound like that? That's actually so true. Because I like to have more chocolate.
Zero.
What?
Because we have a small number.
I like to bite off the top part so I can have like more chocolate. This is
So,
genuinely like.
This is expert.
You're the one talking about me. I don't know what.
Microscopic.
Oh my
Oh. I'm not a big property of the government. Give me my freedom of life.
That works.
I guess that's fair.
Yeah, I think we're ready for the next phase.
Yes. Yes, we are. 100% are.
Teachers, pardon the interruption. We had a bus that was late that I failed to mention earlier. So 782 students are just now arriving. We will work to fix their attendance as well to eliminate the absence that you may have already coded. But just let those students into class when they let you know they're on bus 782.
Dang it, boy. Pretty late.
Okay, I gotta give that to you.
I've got smaller number over bigger number.
This is all mine.
Bigger number gets bigger faster.
I basically, is it of course.
What's it called?
I know you don't.
Oh, it's, I still got it.
Yeah,
It's huge.
like,
I said the right answer.
What does it work?
You don't.
Why does
There's
it
more.
work?
Yes.
What's the word when every zero's at the bottom?
Indeterminate.
Yeah, if you divide by 0, you should pencil this one. Remember that,
Is it fact that we-
Oh, the zero.
Did you already do all this?
No.
What are you doing?
I haven't.
Oh,
I
thank you
don't
for
know.
it. You want mine?
Yeah, but yeah.
Coefficients.
Here, all 36
oh, he's factoring that. Oh, so just plug it out. It's all coming
No, I
back
had
to
236 super score, but then I got nothing for 436. It doesn't matter anymore.
All I want is a 34. I'm 1 point away. And you have a 30. A super score or 34. I had a 33.
Great cigarette.
I don't give a freak about
Yeah, it's
anything.
basically
I
just
just
do
do
it.
it.
Plus 500.
You can take that out.
He did the fastest ever.
Now, let's look at this limit from a different perspective. How did these values affect give x at x?
Doesn't have a steeper slope, so F
R
right.
equal.
I mean, that's gonna be the same.
Yeah. I mean, yeah, because it's going up.
I randomly
Which function
encountered
is taking
branches
a
so
fast
fast.
rate?
So.
So this is 2.
It's a very, well, it's going up. Well,
That
just-
problem is
just-
big.
That is a humongous parameter. I don't know what to tell you. I'm not calling it anything. I'm calling
Whoa,
it.
man.
I didn't say anything.
Hey, focus.
Your walk clock in. Evaluate.
Good job,
So just need a
I'm not gonna pull Steve's first out. I'm not gonna see that should be.
No one squared.
You notice that's 8?
The
Or that it equals the, what is it?
Right.
It equals the, I don't know.
It's just the.
Yeah. Oh, I thought we were playing that in or something.
Oh, equals lower of the div.
Yeah.
It's indeterminate.
When do you think comparing growth rates is a healthy strategy for benefit?
Divide by 0.
Hey, look at you.
Thank you. Keep stepping on my paper.
Miss Moore, did you grade our quizzes?
I did not. I waited for Bryce to finish his. Yeah, I've not graded them yet. I was gonna, I'm gonna get it done this afternoon because I don't have to be at dance until 5. So I just stay here.
3, okay.
This really isn't that long.
So it's just x plus 5.
Honestly surprising.
One is 0 because it's 0. I mean, other is 0 because everything.
Definitely not.
Everything's 0, always. Nothing matters. Nothing's
So I just need to put those for interacting.
Oh, I got ping on it.
We're going to the zero.
Oh, tomorrow?
Yeah, it's somewhere.
Oh, yeah.
Yeah.
You're gonna like
Yeah.
Am I supposed to dress nicely?
Yes.
I have
Wait, it's at 4:30?
Yeah, it's at 4:30.
So I can leave at 4:30.
Hey, afterward, everybody who's going and isn't going, leave school and go to Muya and mention academic service.
So far away. I'm good. Yeah, so far
Wait,
It's literally 7 minutes from here. It's across the street from my house.
I'm good. I wanna go home.
do they have milk
Really
at
reading back
your
there
house?
at your-
Like chocolate milk?
I don't know, but their milkshakes are outstanding.
Their coffee milkshake is so weird. That sounds like I was going. What? I like
I don't know.
Oh,
I'm gonna go home,
chips
change it to my, my.
their fries are really good.
Yeah, they're like.
They do homemade chips. They make their own, yeah, potato chips, but their fries are better.
I'm not sure you should be telling those.
I haven't been, I genuinely like their fries.
I've
But
been twice.
Yeah, tell, the chip, tell, actually, no, well, I wouldn't have one because if we're,
All right, are we ready?
Almost.
no,
Okay.
we and died.
It's a short investigation.
I'm about to start.
bro, no, you hear me out, you kill everyone except for him. When he becomes president, you kill them all.
No, look, hear me out. If you don't kill me, I'm gonna stress you. I was volunteering.
Yeah, and then we have to count people's, the president's. Yeah, but she's gonna be.
I lost mine.
I lost mine.
Like the pipe bomb?
The first time.
Talk about making my phone in school.
No, there was an ingredient, what is the recipe of how to make pipe bomb?
Bro,
Involved,
you're not supposed to talk about this in
chips,
school.
Flour, maybe some eggs. Oh, that was you?
Yeah, I wrote pipe on this.
I thought that was. Where'd you
I
get,
gave it to Connor, and then he passed it around.
where'd you get the recipe?
I think you have to get rid of it.
That's you.
Well,
Even 16.
from his life, his own planet, own planet.
Snow, rain, slam dust.
What? What? What's going on? What? It's not in New York.
What happened? What did you say? New York? Tell me about New York.
Fox weather, snow, rain, slam dust. Winter storms ramp up.
It's like gonna be 70 degrees.
And probably a tornado tomorrow.
Ooh, exciting.
Fun.
Fun times.
Guys, your carrots like that bubble lighter.
My parents.
There was an outbreak.
Y'all, somebody shot my dog this weekend.
They did the other direction.
No, well, it was like birdshot.
No, you're
So he didn't die.
Tornado,
But he's,
tornado takes out every
it
single
hurt. I
person
think he's
that
gonna be
exists.
blind. He's gotten up like twice since Saturday. Like, I don't know.
Tornado.
I know birdshot. What was a shotgun?
I
I mean, yeah, it was shot. Like, it was like, it was like, I think it was a neighbor. When we think he got in a fight with their dog, and then they shot him.
No,
Wait, but if you,
So you should.
so we shot both of them.
No,
I don't know.
So you should shoot your neighbor.
well,
You know, I
No.
you're right, you figure it out.
Came down the door.
I'm sure there's some.
they're kind of
Figure it out.
you don't wanna be
So,
on the guy
yeah,
that shot them because they shot a dog.
Spinning
But they
clockwise,
might shoot us.
right?
So,
If I assume I structured I say all the way.
Okay, we're ready, it sounds
I
like.
think we're just gonna.
What?
That's so sad.
Super, you will win, no jury will not convict somebody for shooting a dog.
Yeah.
Well, we live out.
Animal cruelty. There was a whole article on the front page of the paper about a guy that went to school here that that shot his neighbor's dog, and the dog died, and he shot it with like a pellet gun, but it was a little bitty Pomeranian, and it died.
Honestly, if I was that
It's
dog,
like limping really bad. I almost
I would've
ran.
gone finish
I felt so bad. You like, I get this.
but I did not hear it. I
On
would've-
his bed, which is actually just my feedback. Every day.
Bruh.
Between on it, and like I hadn't touched it all day. And finally he like took an out on it and I was like, "Oh, outside like that," cause he
What
only
makes
gets
him
out.
hard?
Yeah. And he like, same nerve out all of the night, it was right into the wall, 'cause you can't see anything.
Okay, here we go.
I'm not sure that.
So for x squared, as x approaches infinity, what does y do? What does y approach?
Infinity?
Infinity, okay. And then for ln of x, if you don't remember what an ln function looks like, it looks kind of like that, okay. As x approaches infinity, what does f of x approach? It approaches infinity, okay. So which one's growing at a faster rate, f of x or g of x? F of x is growing at a faster rate, okay? How do we know that?
It's exponential.
Yeah, it's, I mean, obviously we could look at the function, okay? If we square something, it's going to grow a lot quicker than if we look at the other one, right? Another thing we can look at are the slopes of the function, all right? So if we look at the slopes of x squared, they're getting steeper a lot quicker than the slopes of ln, okay? So f of x, because the rates of change are getting steeper. Okay. Now, let's think about this limit. Okay. So the limit as x approaches infinity of ln of x over g of x. So ln of x over x squared. Sorry. What do you think that limit's going to approach? Yeah. Did anybody put it in a calculator and look at it? Yeah, I mean, that's always an option, right? They didn't say we couldn't, but we think it approaches 0. Why do we think that? All right, it is infinity over infinity, okay? And this is where I thought it was interesting. We had this idea of medium infinity and large infinity, all right? Who's going to get to a bigger infinity quicker, the numerator or the denominator? the denominator, right? It's going to get to a bigger infinity quicker. And so because of that, we're going to end up with a big number over a really big number, okay, which would imply that we're approaching 0. Okay, if we think about a fraction, a big number over a really big number, we're getting closer and closer and closer to 0. Okay, so because that bottom function grows quicker. Okay. All right, so let's look at this next set of functions. Okay, so it tells me to evaluate f of 3 and g of 3. All right, what did you get for f of 3? 0. And what did you get for g of 3? 0. Why does the direct substitution not work to evaluate that limit of f over g? Yeah, we can't divide by 0, and it's indeterminate. Okay, that was that word we were looking for. It's indeterminate. Okay, so it says, hey, use the factoring method this time, right? We did that early on when we were doing limits. So limit as x approached 3 of x squared plus 2x minus 15 over x minus 3. We could factor, so I get the limit as x approaches 3, x plus 5, x minus 3 over x minus 3. Lucky for us, we're going to lose those x minus 3s, and now we can do direct substitution. So 3 plus 5 gives me 8 as my limit. Okay, so that was one of our methods that we used as well. Okay, but now on number 6, it asked me to look at it from a different perspective. Okay, and so it says, how do the values of f of x and g of x compare at x equals 3? Not a trick question. What did we notice? They're the same. Okay. Okay. So now it becomes which function f of x or g of x is changing at a faster rate at x equals 3. How could we figure that out? How do we find a rate of change at an exact number? We find a derivative. Okay, we take a derivative. So let's do that. Let's evaluate f prime at 3 and g prime at 3. All right, that's our only way to really know who has the faster rate of change. And so if we do f prime, let me go back here and find it, x squared plus 2x minus 15. So f prime is going to equal 2x plus 2, and g prime is going to equal what? 1. And so if we evaluate those at 3, 2 times 3 plus 2, we get 8. And g prime, no, we just get 1. Okay. So if we did the limit of f prime over g prime, I get the limit as x. So who's moving faster? F prime is increasing faster because that's what it wanted to know, sorry. Right, it has a higher rate of change right there at 8. So if we do the limit of 2x plus 2 divided by 1, well, that's just the limit as x approaches 3 of 2x plus 2. And I substitute 2 times 3 plus 2. What do I get? 8. Okay, there's not a coincidence there. Okay, there's not a coincidence. What do you notice? It's the same. Okay, it was the same as when I did that limit with factoring. Okay, so I was able to do the limit of my derivatives as x approached those values. Okay, when do you think comparing growth rates, all right, is a helpful strategy for evaluating limits? Yeah, when I can't substitute. All right, when direct substitution won't work, we can do limits of their growth rates. Remember, growth rates are the same things as their derivatives. Okay, and that's what Logan figured out. Okay, he was like, I ain't got time to do all this algebra. And honestly, could we factor x squared and ln of x to simplify it algebraically? Okay, we couldn't, and nor did he have a graphing calculator or Desmos to throw it on. Okay, so he had to do some investigations into the growth rates and how those were going to help. And so this is what L'Hopital figured out for us. Okay, the reason why we couldn't talk about this, all right, until now is because we didn't know how to take a derivative, but now we do. Okay, so L'Hopital's rule says this. Okay, if the limit as x approaches c of f of x over g of x produces the indeterminate form okay, and the only ones we're required to do in AB are 0, 0, or infinity, infinity. Okay, are there other versions of indeterminate? You betcha. All right, and L'Hopital works for them, but it's a little more involved. Okay, so these are the only ones we have to do. Okay, and all right, so this is the second part. So the first thing we have to show with L'Hopital is we have to show that it's indeterminate, and I'm going to show you what that means. We're going to do a limit sandwich. Okay, a limit sandwich, and the limit as x approaches that constant of f prime of x over g prime at x equals a number. We're going to call it L. Okay, so the limit of the derivatives have to equal a number we can get to. Okay, then that limit we were trying to evaluate of f of x over g of x is equal to that same value that we got from the derivatives. Okay, so that's the formal definition for L'Hopital. Okay, so we have these conditions that are written in orange. All right, we have to produce an indeterminate form, 0 over 0, infinity over infinity, and the limit of the derivatives has to exist. Okay, if it does, then that limit of the original function is the same as the limit of the derivatives. Okay, now here's the cool thing about L'Hopital. It works repeatedly, all right? So sometimes you may do the derivatives and it's still indeterminate. Guess what? We just take another derivative, okay? So it's kind of nice. It's a repetitive process. So always put a caveat, a little note down here. If our result, okay, if it's still indeterminate in that form, 0 over 0 or infinity over infinity, do it again. All right, take another derivative until you get to something that's not. Okay, and it still works. It's just really kind of a beautiful consequence and powerful, to say the least. Okay, so here's what we're going to do. We're going to work on L'Hopital. Everything left are examples, and I want to show you all the different ways, or as many ways as I can, that they might talk to you about L'Hopital. We'll do some multiple choice. We'll do part of a free response. Okay. Okay. All right, rock and roll. So let's take a look at one. Okay. The first thing we have to do is to figure out, can I use L'Hopital's rule? Okay, can I use L'Hopital's rule? Do I have that indeterminate form, 0 over 0 or infinity over infinity? Okay, now we can probably just look at it and know that we can. If I plug 0 in, all right, to the denominator, 5 times 0 is definitely 0, okay? If I plug 0 into the numerator, 1 minus the cosine at 0, okay, 2 times 0 would be 0. What's the cosine at 0? 1, and 1 minus 1 is 0, okay? Well, AP will not let you, on a free response, just do that, okay? You have to state it, and this is our sandwich that I talk about, okay? We take the limit of the numerator as x approaches 0 of 1 minus the cosine of 2x. We know that equals 0, okay? as does the limit as x approaches 0 of 5x. That's your limit sandwich, okay? So your numerator limit equals 0, your denominator limit equals 0, okay? So it's your limit sandwich. Therefore, L'Hopital applies, okay? So on a free response, you have to justify that you can use L'Hopital. Okay. All right. So now that we've justified it, let's go back and let's do the process. The process says, hey, let's take the limit of the derivatives. All right. What would be the derivative of 1? Thank you. 0. What would be the the derivative of negative cosine 2x? Sine of 2x, is that all? Times 2. So a little chain rule right there. And derivative of 5x? 5. Okay. So now let's try direct substitution. Okay. Are we going to get something indeterminate this time? No, okay, because the denominator is 5. So let's plug in 0. So 2 times the sine at 2 times 0 over 5. Okay. What's the sine of 0? 0. We take 0 and we divide it and multiply it by 2. We still get 0. And 0 divided by 5 is 0. Okay. And that's the value of that limit. Okay, what do you think? That's L'Hopital. It's really powerful. All right, doesn't always apply, but when it does, it's great. All right, rock and roll. Let's try this one. So, limit as x approaches 1 of ln of x over x squared minus 1. First of all, we have to prove that it's indeterminate. Is it? Yes. Okay. What's the natural log at 1? 0. And then what's 1 squared minus 1? 0. Okay. So our justification, limit as x approaches 1 of ln of x equals 0, which equals the limit as x approaches 1 of x squared minus 1. Okay, so we know those are both 0. We can sandwich it up. We can do L'Hopital. All right, so we've proved that it works. All right, now, hold a minute. I want a different color. So now, let's do the derivatives. Okay, so the limit as x approaches 1. What's the derivative of ln of x? 1 over x. What's the derivative of x squared minus 1? 2x. Let's do direct substitution. Okay. 1 over 1 divided by 2 times 1, or my limit is 1/2. Okay. So it has to be 0 over 0 or infinity over infinity. Y'all try 5. All right, what do you think? Which, if any, can we use L'Hopital on? The last one, okay? We can use L'Hopital on the last one. On all the others, if we plug in a value, there's an issue. Sin at 0 is 0, but 2 times 0 squared minus 1 is minus 1. So that's what kicks that one out, okay? It's not indeterminate. The next one, sin at 2, all right, and then 2 squared minus 4. We get 0 on the bottom, but sin at 2 is a numerical value, okay? So even though it's 0 on the bottom, it's not indeterminate because it's not 0 over 0, all right? So the last one is the only one where it is indeed indeterminate. Let's take a look at number 6. I like this one. They like everything with a table on AP. You know that, okay? That's not going to go away. They even like L'Hopital that way, all right? So this is where that justification step is really important. Okay, because we want to do the limit as x approaches 3 of f of 2x minus 1. Okay, so let's look at that. The limit as x approaches 3 of f of 2x minus 1. I'm going to physically evaluate that limit for a second since I've got a table. So that would give me the limit as x approaches 3 of f of 2 times 3 minus 1. Which would be the limit as x approaches 3 of f of 5, okay? And what is the value of that function at 5? It is 0, okay? So that gets it, all right? Do we know that that bottom limit is 0? Yes, it's much easier. It's x squared minus 9. So that's going to equal the limit as x approaches 3 of x squared minus 9. Okay, so I can do a little extra work on the front end for that limit because I need it to show that that last one is correct. So now let's do our derivative. Okay, we're going to keep the limit as x approaches 3. All right, now be careful here. All right, what is the derivative of f of 2x minus 1? F prime times 2. Good. It's a chain rule. Yeah, dab it up. There you go. All right. But be careful with those arms. You'll take an eye out. Okay. That dab is aggressive back there. Okay. All right. And then derivative of x squared minus 9. 2x. All right. And so now we're ready to substitute. Okay. So I'm going to take the limit as x approaches, oh, well, I guess I don't need that anymore because I'm going to substitute. So 2 times f prime at 2 times 2 minus 1 over 2 times 3 minus 1, helps if you look at the number, over 2 times 3. Okay, so 2 times f prime at 5 over 6. All right, what is f prime at 5? It is 7. We pull that out of the table as well. So it gives me 2 times 7 divided by 6, 14 over 6, which is 7 over 3. Ta-da! Okay, so we can even use L'Hopital with a table. All right. Okay, rock and roll hoochie coo. Oh gosh, that was aggressive. Okay. Did you draw my little picture that was on the board over there, or did somebody else draw that one? It was on a blue Post-it, that's why I asked. Okay, all right. Because I threw it away because it wasn't very good quality, so I didn't really think it was yours. Okay. It was somebody in my third block. Okay. All right, here we go. Try that one. Try number 7. Multiple choice, so we don't have to prove it. We just need to know we can use it. right, what'd you get? Okay, so we've got some A's and we got some C's.
C.
Okay, well, let's look and see. Okay. All right, so let's double check it to make sure that we can use, so I get e to the 0, which would be 1. Cosine at 0, which is 1. 2 times 0, which is 0, so that's good on the top. And on the bottom, 0 squared minus 0. So I can use L'Hopital, okay? So nope, not that. Let's do a derivative and see what happens, okay? So I'm going to get the limit as x approaches 0. Derivative of e to the x is e to the x. Derivative of a negative cosine, positive sine. Derivative of negative 2x would be negative 2. On the bottom, I'm going to get 2x minus 2. Okay, let's plug in 0. So that's going to give me e to the 0 plus the sine at 0 minus 2 over 2 times 0 minus 2. So I get 1. What is the sine at 0? 0 minus 2 over minus 2. And so that's going to give me a negative 1 on the top over a negative 2, which is a positive 1/2. It is indeed C. Excellent. Be careful with your negatives. They'll try to get you that way. Okay. All right, let's look at number 8. So here's one where it's approaching infinity, all right? And we haven't done one like that as of yet, so let's look at that and see if it works. So I'm taking the natural log of e to the 3x plus x over x, okay? If I take the ln of e to 3 times a big number plus a big number, I've taken the ln of a big number, all right? Which would get me really close to infinity, all right? Over x being infinity, it's infinity. So I get infinity over infinity, okay? Now, let's talk a derivative, right? So I'm going to take the limit as x approaches infinity over 1 over, oh, not that. There we go. 1 over e to the 3x plus x. What's going to be the derivative of e to the 3x plus x? E to the 3x plus 1, and I got to have a 3 next to that e to the 3x because it's composition as well. Okay, so derivative of e to the 3x is 3e to the 3x. All right, all divided by 1. Okay, now I need to simplify that a little bit because that's not really helping me. On the top, I've got 3e to the 3x plus 1 over e to the 3x plus 1. If I divide that all by 1, do I really need that extra divided by 1? No. Okay. Now, if I go to plug in infinity here, all right, 3 times e to infinity plus 1 over e to 3 times infinity plus 1, what's still happening with both of those? It's infinite, okay? E to a really big number is still growing. E to a really big number plus 1 is growing. So we're going to have to do a second derivative this time, okay? So limit as x approaches infinity, okay? Derivative of 3e to the 3x. Yeah, it's going to be 3 times 3e to the 3x, okay? And then what's going to be your derivative of e to the 3x? 3 times e to the x, okay?
Why is it like that again?
Oh, this should be an x right here. Why is it like that?
This
Oh, it's 3x. I forgot. It's always e to whatever power, and then times the derivative of the power. Okay? So, and then there's an extra x right there, so we're going to put a plus 1. All right? So that gives me, if I simplify it, 9e to the 3x over 3e to the 3x plus 1. Okay, so we're getting closer. All right? I plug infinity in again. 9 times e to the infinity. It's infinity. 3e to the infinity plus 1, still infinity. Okay, I'm still indeterminate. I'm still infinity over infinity. So we're going to do another derivative. Okay, so what L'Hopital says we can do. Let's get to something we can work with. Okay, all right, 9e to the 3x. Okay, derivative of e to the 3x is e to the 3x. Keep the 9. Derivative of 3x is 3. 9 times 3 is 27. On the bottom, 3e to the 3x. I'm going to keep the e to the 3x. The derivative of 3x is 3 times the 3 that's already there is 9. All right, now, notice anything? All right, those bad boys go away, right? They go to 1. I got an e to the 3x in the numerator and the denominator. This is the limit as x approaches infinity of 27 over 9. What's that limit just going to be? 3. Okay, so a lot of work to get there. We just had to repeatedly take derivatives to get to something that was not indeterminate. I know, all of that for the number 3. It'd be nice if that was on a calculator section because we could just type it in and look. All right, but it won't be. It'll be on a non-calculator section. Okay, it's how they'll test you for L'Hopital. All right. All right, and then this is a partial released free response question. All right, so we're going to actually look at one. All right, how they ask it in a free response. All right, question on that one where you had to repeatedly do the derivative to make L'Hopital work. And what's funny now is that now we know L'Hopital. A lot of those ones that I could factor really quick and solve that way will do L'Hopital, and sometimes it takes longer with L'Hopital than it does just to factor and reduce. Okay, but you do you, boo. All right, because they both work. All right, if direct substitution does not work and you have an indeterminate form, you can use L'Hopital. All right, so he's your new tool in your toolbox. All right, here we go. So the functions f and h are twice differentiable. There's probably a reason I can take 2 derivatives. Okay, it's just a hunch. All right, with h of 2 is equal to 4. The function h satisfies this equation, x squared minus 4 over 1 minus f of x quantity cubed, when x is not equal to 2. It's known that the limit as x approaches 2 of h of x can be evaluated using L'Hopital's rule. Use the limit as x approaches 2 of h of x to find f at 2 and f prime at 2, and show the work that leads to our answer. Now, y'all, this is a tough problem. Okay, we got to think about how we're going to make it work. Okay, so the one thing that really sticks out to me right here is that it says I can evaluate the limit using L'Hopital's rule. Okay, so I don't have to prove that I can, I'm told that I can. All right, so instead of doing the limit as x approaches 2 of h of x, I'm just going to do the limit as x approaches 2 of h prime. Okay, because they told me I could do it with L'Hopital. All right, so in order to do that, we're going to have to take the derivative of h of x. Okay, its numerator and its denominator. Okay, so this would equal the limit as x approaches 2, right? Derivative of the numerator would be what? 2x, okay? It's L'Hopital, so I'm not doing a quotient rule. I'm doing derivative of numerator and derivative of denominator, okay? So that's where that gets a little bit confuzzled. On the bottom, derivative of 1, Okay, it's subtle. And then minus f of x cubed. So I'd get a minus 3 f of x squared. Is that all? No. Times f prime at x. Okay. All right. So let's plug in what we know. Okay, let's plug in what we know and see what happens from there. Okay. So if I evaluate, that's going to give me 2 times 2 over negative 3 times f at 2 squared times f prime at 2. Okay. Then Oakley, whose office is this?
Oakley.
It's in the main office. Mr. Fretz is down there waiting for him.
Oh, okay.
Wait for me?
Yep. I didn't know who this was. It looked like a big
Right
H at the
now?
bottom. Yes, it's right now.
Got it.
Oh my God. I'm sure it's nothing bad. Oh, I wonder if you're having to do a random drug test.
A what?
Random drug test. They call people out for athletes for a random drug test. Random.
Random drugs. Oh.
She could have gotten pulled. It's the random part, huh?
Parker, you're not an athlete.
Okay. So this is hard, right? Because when we look at this, I really don't have anything that's helping me. Do y'all agree?
Honestly.
They don't do band. They probably should.
Oh, no.
Yeah.
I don't think there's that many. Actually, never mind. I thought about it a little bit harder.
Okay. So,
Drugs they only do it in band.
oh my gosh.
Caffeine pills? Caffeine pills?
Lord.
Well, I mean, I personally really enjoy
Stop.
I do think they
Okay. So, you got to stop. Here, let's look. All right. So, we really, at this point, don't have enough information to finish. Why? I don't know f of 2, but I don't know f prime at 2.
But we can find it.
But we could find them. How could we find it?
F of 2 has to equal 1
Why?
because for that to be L'Hopital, it has to be 0 over 0.
All right. So, let's go back to the original function. In order for L'Hopital to work, that denominator has to equal 0. Okay? And so if we do that, I get negative, oh, that's Bryce. Hold on.
Wait, did Bryce get drug tested for academic?
No. He went to the bathroom.
They can't random drug test, I didn't.
Why?
Because we didn't sign anything in it. Because we're not.
So you guys take steroids for your brain.
Okay, so they put
Brain
it
steroids.
into random drug test guy because they knew.
Random.
Yeah, it was not random, but it was the only one. They drug tested all about you here. I think, at least one.
And it may not be that at all. Just
Me and Sniva drug tested myself. And I think I got tested myself.
all right. So if we get down to it, we end up with f of x cubed. Hey, listen, equals 1, and so f of x equals 1. Okay, and we know that it has to be f at 2 because we're evaluating L'Hopital as x approaches 2. So f of 2 is equal to 1. So I can plug that in. So I've got 4 over negative 3 times 1 squared times, the only other thing I'm missing is f prime at 2. Okay. Thoughts?
When you take
All right, think for a second about what the limit as x approaches to of h of x would have to equal. Because they told you, but they hid it from you. All right, it's twice differentiable. And so if the limit exists, right, that means it's also continuous. And if it's continuous, the value of the function is going to be the same as that limit. Okay, so this limit, this whole limit right here, this tells me that the limit as x approaches 2 of h of x is 4. This comes from continuity and differentiability. That's a lot of things. Welcome to free response. Okay, and this is just one part. Okay, it's one part. So now that we know that, I know this entire thing has to equal 4. Okay, which gives me room to solve for f prime. Okay, it gives me room to solve for f prime. So let's simplify a little bit. So we've got 4 over negative 3 f prime at 2 equals 4. We can do a little cross multiplication here. So negative 12 f prime at 2 is going to equal 4. So f prime at 2 would equal 4 over negative 12 or negative 1/3. Okay, so to finalize our answer, f at 2 was 1, f prime at 2 was negative 1/3. That's a good question. Okay, and a lot going on right there. Okay, so you have to use a lot of things. All right, we're getting really close. After we get through the next unit, we'll be able to do full free response questions. All right, so you'll start seeing what all you can get points for. Okay, but notice how they combine lots of concepts into one question. Okay, and probably that was the last part of that question. So there were some other things above it that might not have been as complex. All right, so, and then there are going to be some free response questions you're like, this is way too easy compared to something like that. All right, and then there's probably going to be one that's harder than that. All right, so just as a heads up. All right, so that's it for today. Okay. Let me give you your assignment. What questions do you have about that bad boy? Because he was intense. Okay, how do you feel about the basics of L'Hopital? Okay, using the derivative. But then when we get to something like that where it's really super complex, you're going to have to think about all the different pieces that go together. Okay, all right, so here's what I did for you. There's a worksheet back there if you wanted a physical copy. But also on page 462. 1 through 8 are really good questions, and then it's that homework 4.7. I think it's 3 questions or 4 that I pulled off of. I might have lied. All right, off of AP Classroom. All right, do your wrap up. Some of y'all are missing the easy points. Just go in and get that done right now before you leave. Okay, your circuit is due by 3:15. Okay, so you can take it with you to the to the movie, I guess. All right. Okay, give me just a second.
Everything good? I don't know. It was a drug test. I put it in my mouth.
Oh, they do it in your mouth?
Yeah, that's what they do.
Oh, you don't have to pee in a cup anymore?
That's what.
No, what?
Pee in a cup?
That's
easy.
Drooled all over.
Yeah,
Gross.
when I did my first year, it had to be, like, they had on, yeah, they're probably 5 minutes to put on. It was like, awkward.
It is awkward.
They were just watching me.
Like, no pressure right now.
What?
Yeah, you're urinating.
Yeah. What about it?
Did you finish?
Are you talking like the,
Those?
Yeah.
Yeah.
yeah, she said she'd give us today and tomorrow.
Where's
Oh,
the?
she's giving us today to get it done.
She wants, like it done today, but she's giving us somewhere maybe. She just doesn't want the whole week. But it should be.
All of the answers are the same, like, I feel like they're asking the same question again.
Okay, hear me out.
I can't even.
Guys, my opinion, movies are not doing it.
Oh,
If we watch it,
no.
I'm not understanding it.
Eliza and I finished our.
Yeah, so, we get negative.
Those three.
Yeah.
I'm just gonna do
AKA
it.
Eliza finished
Sign
ours.
zero.
Yeah, I did well.
And we should probably also find out which age
Yeah,
that was.
that's-
Because we
Still
have,
at one.
Because she
yeah,
way
we
better
should
at
still
this
probably
than-
find.
Right.
That's your task.
Now, hear me out. If you help me find it, I'll do it.
Hey. Hey.
Are you from the world?
Technology should be used in the final stages.
I don't know. I couldn't.
The answer was different.
You should do,
Just got a question about that.
Yeah.
So this one? Like, I understand what it's asking, I don't understand where the values go.
Constant height of 100 feet. While the wind carries it away from him horizontally, so it's staying 100 feet above the ground, so that's staying set. Okay, and here's starting ground at a rate of 2. So this distance is changing because it's moving that direction. Okay, so we'll call this dx dt.
Brakes covered in.
Honestly, it's just where that. That's your hypotenuse.
And the height is, I think it's,
Yeah.
oh, I when you split out 350, so it would be this one, you're right. Yeah, this would be,
And then from there I can solve it. It's
gotcha.
Just, it's just how it works until it confused me.
Yeah,
It's actually really yummy. Like, I'm not even gonna
I think
lie.
cones are really confusing.
they are.
I don't know if I did it. I should probably not look at this work. That's a soft one. It's that there's 2 rates that you're supposed to have.
Has
But
a height of,
It's not what it is.
6, so this is 6, this is 2. And then we've got water in here.
Oh my god. That was so
7, 8.
Oh.
So 2 is to 6.
Yeah, they're making fun of me in the bathroom.
to 8.
Like, oh!
How fast the water is poured in at a rate, so that's volume, and the water is 2 inches deep, so it's H. Okay, so they're giving us H, so we're gonna solve for R, we're gonna take the R out,
yeah, so
okay? So then H equals 3R,
When is he in?
and so R equals 1/3 H, or H over 3. Okay. And then you're gonna take, in this formula, you're gonna take the R out and put the H over 3 in.
that's okay.
Yeah,
That's
so
what
that you only have one rate of change. Yeah. You're welcome.
Now I'll just do
What did you at least solve the mystery?
I'm not entertaining me.